Uh, okay, welcome everyone. Let's get started. Thank you for joining this session of the virtual seminars in economic theory. Today we have Ron Siegel from Penn State, who's going to present the paper, How to Sell Hard Information. We are very pleased to have co-authors Nageeb Ali and Xiao Lin, and a guest panelist, Dan Brown. So the format of this seminars is as follows. We have a 60-minute presentation with time for interim questions from the panelists, followed by a 15-minute session for questions and discussions. So we request all attendees to keep your microphones muted during the talk. However, please post comments and questions in the chat. Nageeb and Xiao will answer clarifying questions in writing and may answer more substantive ones live. There will be another opportunity to ask questions live in the Q&A session at the end. Note that the talk is recorded. Before I hand over to Ron, let me remind you that these seminars take place every Thursday at 4 p.m. UK time. Next week, we will have with us Nicholas Lambert from MIT, who will present the power of referential advice. As usual, you can find more information about the coming list of speakers on our website or by following us on Twitter. Thank you. Ron, the screen is yours.
Thank you very much. It's really a pleasure to be here. And in addition to Nageeb and Xiao, we have another co-author, Nima, who's engaged elsewhere. So what's this paper about? We're interested in situations in which an agent can buy hard information from some intermediary, which he can then use to influence the interaction or terms of trade with a third party. So just some quick examples. Entrepreneurs can benefit from evidence that, that describe the quality and likely sales potential of their innovations or products in their interactions with investors. Sellers of any sorts of assets, whether they're physical or financial, can benefit from evaluations of those assets that they can then show to buyers to obtain better prices. And workers often obtain certification before they engage in looking for jobs with employers. So this is a kind of thing that we mean in terms of obtaining information from an intermediary. Now, you can easily think of very good reasons for such intermediaries to exist, because in such interactions as the ones that I've described and others, they create economic value. For example, they can alleviate agency problems by filtering out bad projects or unscrupulous entrepreneurs. They can certainly facilitate assortative matching between workers and employers or assets and buyers. They can improve the terms of trade by, if I have an asset that I know is valuable, but I can't prove it, if an intermediary allows me to prove it, of course I can get a better price for it. Okay, so this is clear, and this could easily justify why we see intermediaries in many settings. What we're interested in is studying a setting in which an intermediary actually does not provide any economic value. Okay, it does not provide any economic value. The parties, the agent and the parties that the agent would interact with later would actually benefit from the intermediary not existing. And nevertheless, we want to see whether the intermediary can in some way interject herself and somehow guarantee a share of the surplus that she can acquire. So in particular, we're going to ask how much of the surplus that's going to be generated by a trade between the agent and what we'll describe as a market, how much of the surplus that is going to be generated can she capture or appropriate in a robust way. I'll explain what robust means in just a few seconds. And then what kind of information provision would she use in order to attain this, right? Should she provide this information intermediary, should she provide accurate information about, as accurate information as possible? Should she provide some noisy information? And then what kind of fees should she charge for these services? Should she charge upfront fees before the information is provided? Should she charge fees only after the information is provided to the agent, but then only when the agent wants to disclose that information? These are the kinds of questions that we're going to address. The next slide will be the model, so it'll become formal very quickly. But let me just say 2 words on what we mean by robustly. So what we mean by robustly in this paper is across equilibria. So the point of view that we're going to take is that this information intermediary is going to appear, is going to be able to design this information provision setting that will lead to a game between the agent and the party it's going to interact with. The intermediary, while controlling this game, while controlling the design of the game, doesn't actually control the equilibrium that's played. So that's the point of view that we're going to take. So the intermediary we can think of as being cautious, as being unsure of which equilibrium is going to be chosen, and therefore is facing this adversarial equilibrium selection. I'll elaborate on this a little bit later after I put up the model. There will be additional justifications or interpretations for this assumption of adversarial equilibrium selection. So if the broad picture and question are clear, I'll move to the model. Okay, so what we're going to have is an agent that's ultimately going to sell an asset that he owns in a competitive market. Now, the value of the asset will denote as theta, distributed according to some distribution. And importantly, neither party, that is neither the agent, the intermediary, which I haven't yet mentioned, or the market know the value of the asset. And this is important because it'll factor into the fact that the intermediary provides no value. Okay, so we'll see that in just a minute. Right, so this value of the asset is distributed according to some distribution. And now, before the agent goes and tries to sell the asset in the market, there's going to be a profit maximizing intermediary that is going to announce what we call a test fee structure. Okay, so that's going to consist of a test and 2 fees. So let's talk about the test first. A test is what we're familiar with most recently from information design, but there's going to be a mapping from the set of possible values of the asset to the set of signals and to a lottery over signals. And we can think of these signals as scores, right? And importantly, this score is going to be a piece of hard information. So what we mean by that, is if the test is run and some score is realized according to the test, and the agent sees this score, then what the agent can do is either disclose this score or not disclose the score. So formally, the message that the agent can convey to the market when he sees the score S is either the score S or nothing. Okay, so that's what we mean by hard information. Now, just a technical point about the set of scores. It turns out that in this model, the only thing that the score is used for is to infer the expected value of the asset. And so it's without loss of generality to fix the set of possible scores to just be the set of possible, or not the set of possible, the convex hull of the set of possible values of the asset. Okay, so let me just clarify here. We said the set of values for the asset lies in some interval, and the distribution of the actual asset value is some distribution, right? So we're not requiring positive density or anything like that. It could be a discrete set of values, could be a continuous set of values. Okay, so what we're saying is if the only thing that the score is used for is to infer the expected value of the asset conditional on seeing that score, then it's without loss to fix the set of scores to be the entire interval of values between the lowest possible value and the highest possible value of the asset. Okay, that's what we mean by here. Okay, so is it clear what a test is? right? So so this intermediary designs a test and commits to the test and announces the test, right? Concomitantly, the intermediary also announces two fees, a testing fee and a disclosure fee. So a testing fee is the fee that the agent needs to pay in order to have the test run, okay? If he pays the fee, then the intermediary runs the test, and then the agent sees the realized score from the test. He sees that score privately and then decides whether to disclose the score or not. If he chooses to disclose the score, he has to pay this disclosure fee. Okay, if he doesn't disclose the score, he doesn't pay the disclosure fee. Right, so these are the two fees. If he doesn't pay the testing fee, then the test isn't run and he can never disclose anything. Okay, so the next slide, on the next slide, I'll have a timeline of this game more precisely, but I just want to make sure that the elements here are clear.
So just a quick clarification
Sure.
question. So testing, disclosure, both contractable, but the score itself is not. So in particular, prices aren't score dependent here. Sorry, so prices can depend on whether I take the test or not, whether the score is disclosed or not, but they can't depend on the score itself.
Oh, very good. That's right. That's right. So when we're talking about the interaction between the agent and the intermediary, that's absolutely right. So maybe this is a good point to say this. What we're doing here, we're not doing a full-fledged mechanism design exercise, right? One could imagine disclosure fees that depend on the score. One could imagine more complicated mechanisms, dynamic mechanisms. There are all sorts of things that one could do here. On some of these, including score-dependent fees, we have a little bit to say, although I won't say it now because I don't want to be distracted. But we are definitely looking at a restricted class of games from which the intermediary can choose, right? So he can choose these test fee structures. Okay. So as we said, the agent is going to choose initially whether to have the asset tested. Remember, the agent doesn't know the value of the asset, right? No one knows the value of the asset at the outset, and then whether to disclose the resulting score. So let me just highlight here that we see now that the intermediary just doesn't generate any value here, okay? So the asset is going to be sold in a competitive market, right? There's no matching component here in this model. The agent doesn't have any private information that he can use the intermediary to help him disclose to the market, right? If the agent could, what he would like to do is not have the intermediary there at all, just sell the asset to the market, get the expected value, get the entire surplus, and that's it. That would be the end of the story. That's the best thing that the agent could hope for. So the intermediary, to the extent that her services are used in equilibrium, hurts the agent. Okay, so this is what we mean by creates no economic value in this case. So what's the, just graphically again, what's the precise timeline? So initially the intermediary designs and announces this test fee structure, a test fee structure, commits to that. The agent then decides whether to take the test and whether to have the test run on the asset. And if he does, then to pay the fee. Then a score is realized from the distribution associated with the actual value of the asset. The agent observes this score if the test is run, and then decides whether to disclose the score or not to disclose it. Okay, the market sees either the score being disclosed or nothing being disclosed. And critically here, if the market sees nothing, then the market can't distinguish between the test not having been run and the test having been run, and the score realized, but the agent choosing not to disclose this score. Okay, so that's a critical feature here, which is what's going to make it impossible for the agent to commit not to use the services of the intermediary. Okay. So what is going to be the price that the agent is going to get for the asset? Well, if the score S is realized, right? So what is the market going to offer? The market is going to offer, the market is competitive, it's going to offer the expected value of the asset conditional on what the market observes, which is either a particular score or nothing. N, right? If the score is disclosed, then there's nothing else to say. The score we said is normalized to be the expected value of the asset, right? The intermediary commits to this mechanism, to this test fee structure, so there's no problem. The issue is that the price following non-disclosure, that is going to depend on the equilibrium, namely on the behavior that the market expects from the agent, right? And we'll see this in the next slide when I start with an example. Okay, so that's kind of the critical thing. As I said in the previous slide, you can see from this that the agent would benefit from not using the intermediary services. He's not getting anything from this relative to the ex ante possibility of just getting the expected value of the asset. And the value from the price that he's going to get from non-disclosure is going to depend on the equilibrium. Okay, where by equilibrium we mean the gain between the agent and the market, right? The gain that's here on the slide, after the intermediary has already fixed the test fee structure. Okay, so all right. So what I'd like to do now, what I'll do now is I'll give an example to highlight this issue with multiplicity of equilibria and how the value of the asset, the price of the asset is going to be determined in different equilibria. That will raise this problem of adversarial equilibrium selection, which I'll formalize, and then I'll give you an overview of the results, and then we'll develop the main intuition through a variant of the same example. That's what we'll see. Okay, right, so we're interested in the test fee structure that the intermediary is going to choose to maximize her profit. Okay, so let's start with, as I said, with an example. Suppose that the asset value is binary. It's either 0 or 1, each with equal probability. And to illustrate the point that I want in this example, which is the multiplicity of equilibria, we can shut down one of the fees. So let's just use a testing fee. Okay, suppose that the intermediary only charges a testing fee, that's an upfront fee, doesn't charge any disclosure fee. Also, let's look at the simplest test, which is the fully revealing test, right? Namely, if the asset's value is 0, then the score is 0. If the asset's value is 1, then the score is 1. Right? So we're looking at a particular test. We're fixing the disclosure fee to be 0. We're looking at just a testing fee. Okay. So, sorry, and we're fixing also the testing fee for now to be 1/2. So let's look at what equilibria arise in the induced disclosure gain between the agent and the market. So here's one equilibrium. There's an equilibrium in which the agent pays for the test, so the test is run, and then discloses the score if and only if it's 1, okay, which means that the asset value is 1. The claim is that this is an equilibrium. Let's just verify this. Well, if the agent doesn't disclose anything, since the market expects the agent to disclose, if and only if the score is 1, the market concludes that the asset value is 0, and therefore will offer a price of 0. Okay. If the agent follows the equilibrium prescription, then he should take the test. Then what is he going to do? Well, with probability 1/2, the test is going to tell him that the asset value is 1, and then he's going to disclose this and get a price of 1. With probability 1/2, he's going to get the values of the asset is going to be 0, and then he can disclose that and get 0, or not disclose it. So in particular, he won't disclose it and get 0. Okay. So if he takes the test, he's going to get a half. Okay, now the price of the test for any price lower or equal to a half, therefore it's optimal for him to pay for the test. So what we see here is that the intermediary, by offering a fully revealing test and charging an upfront fee of 1/2, can get the agent to take the test in some equilibrium and pay him the entire surplus, right? The expected value of the asset is 1/2, and the intermediary can get that entire value. Okay, so why isn't this the end of the talk, right? So we just saw that, well, because I have a few more minutes, but is there any more content to discuss here, right? So we saw that an intermediary who creates no value can nevertheless offer a fully revealing test, charge a high upfront fee, extract everything, get the agent to take that test. The problem is that this same game has another equilibrium. Okay, the problem for the intermediary is that there's another equilibrium, right? Suppose, and in this equilibrium, the agent doesn't take the test. So now suppose the market expects the agent not to take the test. Okay, then if there's no disclosure, which is what the market expects, then the market will offer the expected value of the asset, because the market expects no disclosure, which is a half. Now here's the key point. The agent can secretly take the test, right? The market doesn't observe whether the agent takes the test or not. The market only observes whether a score is released or not. So the agent can take the test secretly and then disclose if the score is 1 and keep quiet if the score is 0. So what would he get? Well, if the score is 1, what he would get relative to keeping quiet, he would get 1 instead of 1/2. If it turns out the score is 0, then he's just going to keep quiet and he's not going to get anything relative to the half, right? So his option value from secretly taking the test when he's not supposed to is worth 1/4. But if the testing fee is 1/2, then that option value is not worthwhile. So this shows that if the testing fee is 1/2 and the test is fully revealing, there is an equilibrium in which the intermediary makes no profit. Okay, so that's the problem that the intermediary has to deal with. If we give the intermediary a lot of power and he can also specify the equilibrium, fine. But if we want to see whether the intermediary can kind of force himself and generate some profit, then this is a problem for the intermediary. Now you might say this is some special feature of this example. We have a result that says, in fact, in the general model with general distributions of valuations and general tests and so on and so forth, if you have a test fee structure and an equilibrium in that test fee structure where the entire surplus, or approximately the entire surplus, is extracted by the intermediary, then there will be another equilibrium with almost 0 profit. Okay, so this is a general problem that the intermediary is facing. All right, so what is going to be our approach? Now we can kind of formalize the problem. The problem that we're going to study is maximizing across test fee structures, right? Choosing the test fee structure that gives the highest profit in the worst equilibrium for the intermediary, right? So for every test fee structure, there's going to be a set of equilibria. We look at the equilibrium that has the lowest profit for the intermediary, and then we find the test fee structure that gives us that highest guarantee. Okay. Now I'm writing sup and inf. I should have just written max and min. There is a slight technical point. I'm just going to gloss over it at this point. Maybe we can discuss it at the end. I don't want to get sidetracked. But what we're doing is, again, finding the test fee structure that maximizes the profit guarantee or the revenue guarantee of the intermediary across all equilibrium. Okay, so this is different from standard mechanism design where we're assuming that the designer chooses both the mechanism and the equilibrium, right? That's partial implementation. Here we're working on the worst equilibrium. So that's adversarial equilibrium selection. Now, another justification for this adversarial equilibrium selection is that the worst equilibrium in terms of profit for the intermediary also turns out to be the best equilibrium for the agent. And why is that? Because the overall surplus in any equilibrium is just the expected value of the asset, right? So the lowest profit for the intermediary means the highest profit for the agent. The market gets zero, it's competitive, right? So if we think that the agent and the market can coordinate on the best equilibrium for the agent, then that will give us the worst equilibrium for the intermediary. Also, when we view the disclosure game between the agent and the market, it's the most efficient equilibrium for this reason, right? So if we choose the efficient equilibrium, the one that maximizes the sum of payoffs for the agent and the market, that is the worst equilibrium for the intermediary. Okay, so that's what we're studying. So as we said, the intermediary has a problem because she's providing a service that has no value, right? So how is she going to convince the agent to take this? How's she going to force, in some sense, the agent to use her services? Well, she has to do two things. First, she has to make sure that in the test fee structure that she designs, the asset is going to be tested in every equilibrium, because if the asset is not tested, right, if the agent decides not to test the asset, then the revenue is going to be zero. So how does she do that? There's going to have to be option value of the kind that I described, right, where the agent would like to secretly deviate to take the test if the market expects him not to take the test. How do you generate this option value? Well, you want to make sure that you don't charge high disclosure fees so that there is some actual benefit from disclosing. On the other hand, if you charge positive disclosure fees, which are low, you actually get more revenue from those too. So both of these forces mean that the intermediary wants to make sure that the agent discloses with high probability in every equilibrium. Now, another thing that we can point out here, which is slightly different from the standard mechanism design setting, is that a deviation here is deviation across equilibrium, right? There are two challenges. First, we want to have an equilibrium. So we want to make sure that the agent does what he's supposed to in this equilibrium, but also the deviation is the existence of another equilibrium, right? That's the concern that we have. So that's going to affect the structure of the solution here. Okay, so one thing that we can say, it's a result, if the intermediary could charge only a testing fee, as she did in the example we just looked at, right? No disclosure fee, just a testing fee, then in fact, what we saw is optimal. And that has nothing to do with the binary value of the asset, right? If testing fee is the only thing that the intermediary could charge, then the best thing that she can do is actually the fully revealing test, and then choose the highest testing fee that is consistent with the agent actually taking the test. Okay, which is, in this example that we just saw, would give a profit of 1/4 because that's the highest testing fee that the intermediary could charge. Okay, so the interesting part arises because we're considering also disclosure fees. And it turns out that if the intermediary can charge disclosure fees, which we're of course allowing, and also a combination of testing fee and disclosure fees, then optimal test fee structures, and in particular optimal tests, have a very different structure. They're necessarily noisy, and they necessarily include a lot of noise, even if the asset value is only binary or has just a few possible number of values. So what we show is that an optimal test, where now what I'm describing in this graph is the distribution of scores in this test. Okay, this is not conditional on any particular value, but averaged across values, right? So this is the ex-ante distribution of scores in the test. So what we have here on the x-axis is the score, on the y-axis is the CDF of that score, and the key point is this intermediate region. So what this diagram shows is that there's always an optimal test fee structure where the optimal test consists of 3 regions. So 2 atoms and 1 interval of scores. So there are going to be two atoms of scores, one low score, which is going to arise with positive probability, possibly one high score, which arises with positive probability, and an intermediate range of scores where these scores are distributed exponentially, okay, where this distribution is exponential. So in particular, an optimal test is going to have a continuum of scores, even if the asset value is binary. Okay, so that's one feature of any optimal test fee structure. The second is that the disclosure fee, which is what's going to drive this, as we said, the disclosure fee is necessarily always positive. The testing fee is not necessarily always positive. We'll talk about that later, but disclosure fee is necessarily always positive. Finally, the intermediary can guarantee herself a positive share of the surplus, but cannot extract the full surplus. And we already saw that, right? We said whenever there's an equilibrium where she can extract the full surplus, there's going to be another one where she gets almost zero. In fact, our result identifies the upper bound and shows that it's tight for some distribution evaluations. We'll look at that a little bit later. How do we show this? Well, we're going to develop, mainly for intuition reasons, a demand curve approach that ties this constraint of deviating to another equilibrium and describing that with a demand curve that's going to generate this result of the optimal distribution, the optimal test having this exponential distribution. Okay, so the way I'm going to do this, I'm not going to have any formal proofs. What I'm going to have, I'm just going to continue with that example and show you how we can reach this exponential distribution optimally by using disclosure fees, right? Because that's what's going to drive this. We're going to do this in two stages, and then I'll just describe the result in greater detail. Okay, so let's shut down the testing fee. Let's shut down the testing fee because it's not needed to show this feature of the exponential distribution. We're still considering a binary, the same binary value distribution. It's either 0 or 1 with probability half. Now the intermediary is going to use only a disclosure fee. Okay. And let's also start with a fully revealing test. So the test says 0 if the asset value is 0, 1 if the asset value is 1. And we're going to consider the different equilibria of the test for varying disclosure fees, between 0 and 1. Right? Now the testing fee is 0, so if the asset is tested, what's going to be the intermediary's profit? It's just going to be the disclosure fee times the probability of disclosure. So first, let's see that indeed there's always going to be an equilibrium, just like before, in which the asset is tested and the score is disclosed if and only if it's 1. Okay, so again, the claim here, fully revealing test, 0 testing fee, a disclosure fee, which is some number between 0 and 1. Claim there's always an equilibrium in which the agent has the asset tested and discloses if and only if the score is 1. Why is that? Well, no disclosure is going to lead to a price of 0 because the market expects disclosure if and only if the score is 1. What does the agent get from taking the test? Well, if the test score is 1, which happens with probability half, then what the agent is going to get is 1 from the market if he discloses, right? But he's going to pay the disclosure fee. Otherwise, he's not going to pay the disclosure fee. He's just going to get 0, which is what the market expects given no disclosure. So this is the expected payoff of the agent, which as long as the disclosure fee doesn't exceed 1 is non-negative. So that's fine, right? So the agent is willing to have the asset tested. Is this clear? Right. So there is an equilibrium in which the agent has the asset tested and discloses the score if and only if the score is 1. That's for any disclosure fee between 0 and 1. So again, if the intermediary could choose the equilibrium, she would just have a disclosure fee of 1 and extract the full surplus. But as we already know, there's going to be another equilibrium, which is problematic, right? So it turns out if the agent if the intermediary charges a fee that's a half or higher, right? And she would in particular need to charge a fee of 1 to get full extraction. If she charges any fee that's a half or higher, there are other equilibria. And it turns out that there are 2 other equilibria. One equilibrium is the equilibrium in which the agent does not have the asset test, has the asset tested, but does not disclose the test score. Okay, so remember the testing fee is 0, so it doesn't cost anything to have the asset tested here, but the agent won't disclose the test score. And for a similar logic to what we saw before, following no disclosure, when the market expects no disclosure, it's going to be a price of a half. If the agent discloses, he has to pay the disclosure fee. If the disclosure fee is a half or higher, then that's not a profitable deviation. Okay. Now, there's also a third equilibrium. This is a mixed strategy equilibrium. In this equilibrium, the agent doesn't disclose a score of 0, but does disclose a score of 1 with positive probability. Okay. And the higher the disclosure fee is, the higher the probability with which he discloses. And what's the idea there? The idea there is, what is going to be the market's belief upon seeing no disclosure? Well, who doesn't disclose? A score of 0 doesn't disclose, and a score of 1 doesn't disclose with some probability. Now, the lower the probability of disclosure, right, the more favorable the market's expectations are following non-disclosure. So in order to make the agent indifferent between disclosing and non-disclosing, right, so the agent is going to be willing to pay a higher and higher disclosure fee, can only follow if the market's expectations following non-disclosure are more and more pessimistic. Right, so the agent is willing to pay a higher disclosure fee to avoid the market believing that the asset has low value. And that's why the probability of disclosure increases in this mixed strategy equilibrium, increases in the disclosure fee. Okay. So what we conclude here is that if the test is fully revealing and the testing fee is 0, then the best that the intermediary can do in terms of charging a disclosure fee is to charge a disclosure fee slightly less than a half, right? In which case the agent will have the asset tested and disclose the score anytime that the score is 1, which is with probability half, and that's going to give a profit of 1/4. Okay, this slightly less than a half is closely related to the soup inf that I described before. We can all see that we would have to deal with this little technical issue, which I'm not going to talk about in detail. Okay, all right, so how do we make progress, right? All I showed you here is that you can do exactly the same with a disclosure fee that you can do with a testing fee. The difference is that now with a disclosure fee, which we saw before, you can't do any better. It won't help the intermediary to change the test. The best thing that she could do is what we saw. But when we're allowing for disclosure fees, now the intermediary can do better. Okay, there's a way to change the test in order to get a higher revenue guarantee from the agent. Okay, so I'm going to show you this. But before I do that, I want to translate what we just saw here in some formula to this graphical demand curve representation that I mentioned will be useful for us. Okay, so let's think about the disclosure fee on the y-axis. Let's think about the equilibrium probability of disclosure on the x-axis. Okay, in this particular fully revealing test with a testing fee of 0. What did we see? We saw that whenever the disclosure fee is a half or higher, the only equilibrium that we have, I didn't argue that. Sorry, that's also not true. We have an equilibrium, we have an equilibrium in which the agent does not disclose. Right? The agent takes a test, does not disclose. On the other hand, we saw that for any fee less than 1, there is an equilibrium in which the agent takes a test and discloses a score of 1. And then I also said and argued kind of informally that for disclosure fees a half or higher, there's a mixed strategy equilibrium where the disclosure probability increases in the fee. Okay, so we can see that for disclosure fees that are half or higher, there are 3 equilibria. Right? For disclosure fees that are less than a half, there's only this 1 equilibrium, in which is the equilibrium in which the high score is disclosed. Is this all right? Now we're interested in adversarial equilibrium selection. We're worried about the worst equilibrium. So this is going to be, if we just trace out the worst equilibrium for any disclosure fee, right? For any disclosure fee, we're looking at the equilibrium with the lowest disclosure probability. This is the equilibrium with the lowest revenue for the intermediary. That's going to generate this, what we call robust demand curve or inverse demand curve for testing. Okay. What is going to be the intermediary's profit from any particular disclosure fee? Well, it's just going to be the area under the curve at the chosen disclosure fee. So what would the intermediary want to do? He would like to raise it as high as possible, just slightly under 1/2, and capture this entire surplus, which is 1/4. Okay, so that's just drawing what I described in the previous slide. But why is this helpful? Because you can see that really what the intermediary is benefiting from is only this robust demand curve. There's this area right here, which is not doing any work for him. Now, that's a very informal statement, but let me show you now how we can modify the test in a way that increases the intermediary's profit in the worst equilibrium, and how that change is going to affect the shape of this demand curve and this robust demand curve. Okay, so let's go back to the example. We again have no testing fee, but instead of having a fully revealing test, let's have a noisy test. Let's add an intermediate score of 3/4, right? So we have a score of 0, we have a score of 1, but now we have a score of 3/4 as well. What does that mean? Well, if the actual value is 0, then with some probability, a score of 0 is going to be disclosed, but with some probability, a score of 3/4 is going to be disclosed. And similarly for a score of 1, of course, the ratio of these probabilities has to be such that the expected value conditional on this score is indeed 3/4. Okay, so if we say that the probability of this score, the ex-ante probability of this score is P, these are going to be the probabilities of score 0 and 1. Is that okay? Right? What's the idea here? What we want to do is we want to have the agent disclose a score of 3/4 as well. If we can get the agent to disclose a score of 3/4, then we will have improved the situation for the intermediary, because then that means that the agent is not only paying the disclosure fee when the value is 1, but also with some probability when the value of the asset is 0. Right? We're going to pool a little bit from 0 and from 1, and that's going to allow us to include some value 0 as scores that the agent will disclose. Is that clear, right? So we want this to be an equilibrium for the agent to disclose a value of 3/4 and a value of a score of 3/4 and a score of 1. But we want to do it carefully so as not to generate equilibria that are bad. What's a bad equilibrium? Well, one bad equilibrium is that the agent is just not going to disclose. Well, we're going to take care of that. We're going to fix the disclosure fee at slightly less than 1/2. So that's going to take care of the agent not disclosing, as we saw previously. We also want to make sure that there's no equilibrium in which only score 1 discloses, but score 3/4 doesn't. Okay, that's another bad equilibrium for us as intermediaries. Okay, so what do we need to do? This is this cross equilibrium constraint. We want to make sure that we can break this equilibrium, this potential equilibrium. Namely, if the market expects the agent only to disclose a score of 1 and not to disclose a score of 3/4 or 0, the agent would like to deviate and disclose a score of 3/4. Okay, and that's going to kill that equilibrium. So, or break that equilibrium, too violent, right? So, so how do we do this? Well, on the right-hand side, so we're looking at an equilibrium in which the agent took the test, received a score of 3/4, and now he's asking himself, should I disclose it? Well, if he does disclose it, he's going to get the market price of 3/4. He's going to pay the disclosure fee. Now, if the market expects him not to disclose a score of 3/4, that means that if he doesn't disclose, what is he going to get? Well, he's going to get the conditional expected value of not disclosure, which is 0 with this probability, 0.75 with probability P, and the conditional probability is just the sum of these two probabilities, right? So this is going to be the price following non-disclosure if the market expects disclosure only if the score is 1. And to break this equilibrium requires this inequality. Is this clear? This, in some sense, is the key step.
Sorry, so a potentially silly clarification question.
Yeah,
Apologize. The 0.75 here, you could imagine, other mixtures. Is it important that it's 0.75 at all? I could make this argument with okay, 0.75 more or less picked at random. Is there a sense in which that's sort of like the right one or the optimal one if I can only pick one mixture? Or
I don't know that this is this the optimal one if we can only pick one? I don't remember if that's the case.
I don't think we know the answer to that question.
I don't think so. Okay. No, so all I'm trying to do here, and you're absolutely right, is just to show how we can do better than a fully disclosing test when we're allowed to use a disclosure fee, something that we couldn't have benefited from with a testing fee. I didn't prove that, but that's to you, but that's indeed true. So let's see what kind of constraint that implies on P. Well, if you just solve this, what you'll see is that P has to be smaller than some number, than 2/9 in this case. And why is that? Look, if P is very high, then conditional on non-disclosure, the market believes the asset is very likely to be of value 3/4. So the agent certainly wouldn't want to pay a disclosure fee of 1/2 to get the value 3/4, right? So you can see, of course, if I lowered the disclosure fee, I could get a higher P, and there's certainly a trade-off, but fixing the disclosure fee at whatever I could get with a fully revealing test, there's still slack that's coming from the fact that a score of 1 in the fully revealing test had a lot of surplus when the disclosure fee was 1/2. Okay. And so we can add this intermediate score, which allows us to pull some of the 0 values and still get disclosure in the worst equilibrium for both of these scores. So what would that look like graphically? Now we're going to have this. Okay, before, remember, we had just this one line came all the way up to here, and then we had this. Now we have this intermediate region. What does this correspond to? Well, this part is still corresponding to an equilibrium in which the agent doesn't reveal his score. Now we have a region in which the agent only discloses a score of 1. And here we have the agent disclosing both a score of 3/4 and of 1, right? So for any, again, the fee on the y-axis gives us the several equilibria on the x-axis. And these downward sloping lines correspond to mixed strategy equilibria in which the agent here is either mixing between disclosing and non-disclosing a score of 3/4, but always reveals a score of 1. And here he doesn't reveal a score of 1, but mixes between disclosing and not disclosing a score of 3/4. Okay. What's important here is that this line, the vertical line here, is to the right of 1/2. Okay. So you can see we actually were able to push this line to the right by eating up some of the slack that we had up here. Okay, so it's just informal, but you saw how we did that formally, right? But this is kind of the intuition that there was some slack up there, and that slack we can think of as the fact that a score of 1 actually had a high payoff in that equilibrium in the fully revealing test. We took away some of that by we took away some of that slack by introducing this intermediate score. Okay, so that's the idea. And now comes the question. Okay, so we introduced one score. Can we introduce other scores? Should we introduce this score, maybe something else, and so on and so forth? So how do we go about this? Well, we just follow this intuition, right? Different tests, we saw two of them, are going to give us these different demand correspondences. And we saw that the intermediary's payoff is the largest rectangle that fits under this curve. So anything above the rectangle is kind of wasted, right? It's not generating any profit for the intermediary. So we start from this slack, we moved here. Ideally, we would like to move all the way here, right? To just flatten this demand curve all the way and thereby leave no slack. If we could do that, what would that correspond to? It would correspond to, at this particular phi of 1/2, having a continuum of equilibria, right? For every score here, we would have an equilibrium where any realized score above it discloses, any score below it doesn't disclose, right? And if we could do this, and it would allow us to push things to the right, we would get extra revenue here, okay? So let's write out, so what does it mean to have a continuum of equilibria? Well, that actually just gives us a differential equation. Let's see that, right? So if we are fixing, in this example, disclosure phi to be at 1/2, and we said there's a continuum of equilibria there and some interval of scores, what is that? What does each equilibrium look like? Well, it has to be that this marginal score is just indifferent from disclosing, indifferent between disclosing and not disclosing, given that the market expects that score to be the marginal score. So that no disclosure means that the market expects the score to be at most that score, right? So again, this line right here mathematically corresponds to having this equation hold for an interval of scores S. Is this clear? Okay. So now we just write out what this equation is. Well, this is conditional expectation. We can write the expectation as the integral of 1 minus the CDF. That's what we do here. We move the S to one side. We realize that this is the derivative of this log. We can solve it. This gives us an exponential distribution. Okay. That's it. So if we have an exponential distribution, then we obtain exactly that demand curve, right? Which in this case, if we describe it as a CDF of the scores, is going to look like this. The score 0 is going to be realized with probability 1/e, right? So that means that whenever the actual value is 0, then with probability 2/, which happens with probability 1/2, then with probability 2/e, the test gives a score of 0. Okay, and with the remaining probability is going to pool that value 0 with the value 1. And how is it going to do that? Using this exponential distribution over scores. Does that make sense? Right, so we have that the distribution of scores has only one atom. That's the expected value conditional on the score not being disclosed. That's 0. It's going to arise with some probability. And then we have an exponential distribution of scores that start from 1/2 and go all the way up to 1. And remember, this is for a testing fee, for a disclosure fee of 1/2, or approximately 1/2. So now going back to Dan's point, notice that the lowest score that is going to disclose is, of course, getting no surplus, right? That wasn't the case when we started with the fully revealing test, because in the fully revealing test, a score of 1 had a surplus of 1/2. We could remove some of that by having a richer test, a noisier test, right? And ultimately what we're doing, we're flattening the whole thing and not leaving any surplus to this lowest guy. Okay. So we can see that even though the asset value is binary, this robust profit maximization gives us a noisy test with a continuum of scores. And that's going to be a general feature, right? and we can compute the intermediary's profit. It's going to be this amount, which is higher than a quarter, which is what we had in the fully revealing test, lower than a half. We can't get everything. We already saw that. Turns out that this is the optimal test fee structure in this example. And we also prove that this is the upper bound of what the intermediary could achieve. There's a formula, which I'll show you in a minute. Let's see how we're in time. I'll have just a few minutes. That shows that this is really the highest that you could get in any example, in some sense. Okay, so now I gave you the main intuition. This is kind of what we get. So without going into any details, let's take a step back. And what can we say about if we have both testing fees and disclosure fees? Right now we shut down the testing fee and we just saw what we can do with disclosure fees. Well, we will still get that it's optimal to have some form of a rectangular demand curve, namely a flat line, a region of a continuum of these equilibria that are characterized by the exponential distribution. So that's one observation. And then, of course, we ask, can we actually implement this, right? And that answer, and the answer to that depends on what we all know is Bayes plausibility, right? So these tests are restricted. They have to respect Bayes law, Bayes rule, right? Because we know what the asset distribution is. All these tests can do is just add more noise. That's all the tests can do. It turns out that you can nevertheless generate this rectangular demand curve because all it is really having the right kind of noise. Okay. And then a small remaining component is that we assume that the asset was tested. We guaranteed that by having a testing fee of 0. But more generally, it turns out that it's optimal to use both testing fees and disclosure fees. So there's another condition that guarantees that in terms of which fees to charge. I think I'm going to skip that. It uses kind of the similar idea. Remember, with the disclosure fees, we were worried about charging a high disclosure fee because that would generate another equilibrium with less disclosure. The thing we're concerned about with testing fees is generating an equilibrium where the asset isn't tested. It's the same kind of constraint with just a different equilibrium. I'm just going to skip that. It generates this equation. So the upshot is that when we're allowed to use both testing fees and disclosure fees, we're going to have an optimal test in what we call the exponential step class of distributions, which has an atom at some low score, which is the market's expected value of the asset conditional on no testing, conditional on no score being disclosed. Then we have a distribution, an exponential distribution of scores in some intervals, all of which are going to be disclosed in equilibrium. And then we may or may not have an additional score, a high score, which arises with positive probability. In the example with 2 values, we didn't have this, right? Remember, this exponential thing went all the way up from 1/2 to 1. In general, we may have this. When does this occur? It occurs whenever it's optimal to charge a positive testing fee. Okay, so if it turns out that it is optimal to charge a positive testing fee, then we will have this additional high score that arises with positive probability. So this is the formalization of this theorem. We're going to have an optimal test fee structure in the exponential step class. It will always have, any optimal test fee structure will have a strictly positive disclosure fee. I didn't stress that recently, but I will now. It always has a strictly positive testing fee, may or may not have a strictly positive disclosure fee. It does if and only if there is that additional score that arises with positive probability at the top. And we have a formula for the maximal robust payoff guarantee as a function of some properties of the distribution, right? The expected value in the upper and lower bounds. And in fact, this guarantee is attained whenever we have a binary support. Okay, so one thing that you may ask is, okay, so when are you going to use a testing fee? When are you not going to use a testing fee? So we have some sufficient conditions for both. Whenever you have binary support, as in the example, in fact, you will not use a testing fee. So it's optimal not to use a testing fee. And if you have log concave distributions of the value, then you will want to use a testing fee. Okay. What's special about this binary support that comes up a couple of times? Well, with binary support, the restriction that Bayes' rule imposes is only that the expected value of the distribution is equal to the expected value of the original value distribution. The second order stochastic dominance constraint has no bite there. Okay, with more than two values, there's this additional constraint, and it may, as we see with long concave assets, have bite, and then it will induce a positive testing fee. Okay, so again, it's not a very important point, so I just gave it to you quickly. I'm out of time. I mean, I started 11:02, but so let me end now. So we considered a profit maximizing intermediary, right? Doesn't provide any economic value by selling this hard information, and is facing this problem of not being able to choose the equilibrium. And nevertheless, we saw that this intermediary can guarantee some surplus extraction, and she does this by having optimally noisy tests, even if the asset valuation is binary or has a small support, and by using positive disclosure fees always. Testing fees may or may not be zero. And we have various extensions. Maybe Dan would like to raise some of this. We can talk about what if not all tests are available, what if testing, what if different tests are costly to the intermediary, what if the intermediary could offer not just a single score, but multiple pieces of evidence. There are several extensions that we know something about. All right, thank you. I'll stop here.
Thank you, Ron. Dan, do you want to talk, or do you want to make any comments, or?
Sure. So I guess I can kick off the question and answer part of the talk. So first of all, thank you very much for the presentation. It's a super interesting. I found it like a super thought-provoking model to think about, and actually the paper was really fun to read as well. So thank you for that. So one question I have sort of builds on the first question I asked during the talk, which is about elaborations on the contracting space. And you could imagine, right? I raised sort of signal dependent pricing. You can imagine lots of elaborations. What I'm really wondering about in some ways is some of the multiplicity of equilibria and the impossibility of full extraction in some ways feels very robust to a lot of elaborations you could imagine, right? If no one's buying, then that sort of puts a cap on what anybody is willing to pay for it. And so that seems right. In some sense, I got to this question. So is there a way to get to full extraction? Is there an elaboration that sort of gets you there? Or is it really sort of, no matter how you enrich the contracting space, you're just never going to get to full extraction because there's always this coordination problem? And then sort of what's the right benchmark? As I think about richer contracting environments, what is sort of the right benchmark for where we should be aiming if it's not full extraction? Sorry, that's a very speculative question, but yeah.
Right. So I don't know. I don't know if there's anything really useful for us that we can say about this, right? So, we don't have. So here, I think the problem, or let me just illustrate a problem. So what one would like to say is something like, here is the class of mechanisms that we allow. And in this class, which is larger than the class that we're considering with test fee structures, we still have the result that whenever there's a fully extractive test, right, there's one with low profit, something like that, right? So we don't have a result like that. And one of the difficulties is that with more general mechanisms, finding the equilibria is quite challenging, because you could imagine some dynamic, right? Some dynamics, and then signaling becomes part of the issue. You give the agent some information and then maybe additional information. So the fact that it's one shot here, it's on purpose, right? So I don't know that we would have an easy way to do this. What I can say in the opposite direction is that if you know, there are changes to this setting which would make things even worse for the intermediary. It's in the opposite direction of what you're asking, right? So if the agent could be observed to take or not take the test, then the agent could commit not to take the test, right? So that's in the other direction. What we do know is that some elaborations, like having score dependent disclosure fees, don't get you all the way there. Okay. I don't know that we can formally say more. Is that more or less precise? Nageeb, what do you think? Yeah. You're pushing the envelope, and you're there with us. I mean, that's what we know. Yeah. Go ahead. Sorry.
So I'm happy to. I have tons of questions, so I'm happy to ask another if that's okay. So sort of a question / comment. So thinking towards sort of implications of this model, one of the things I found really striking about the resulting sort of optimal testing scheme is that it combines, sort of obscuring information or providing not full information with complexity. And when I think about sort of tests in applications, when I think about, for instance, assigning grades to students, right? It is absolutely obscuring some information, but it's moving towards more discreteness. It's this combination of like, we're offering a very rich test that is also not very revealing, even if the underlying facts that we want to know are in some sense very simple, that I found very striking. And even as I say this, what do I mean by like a very complex test and stuff? So sort of thinking through what that would mean in practice, or thinking through what applications that sort of combination of complexity and obfuscation is I think would be a hard thing to do, given that I'm having trouble even like saying it. But I think it's a really striking kind of implication of the model that popped out to me, at least. So that's more of a comment than a question. Sorry.
Good. No, so this comment, if I can say something. So this comment brings to mind a couple of things that I didn't say about this frightening thing called reality, or connection to reality, right? So one thing, so we can say a few things here. One is that, and this relates to the motivation, you see these intermediaries everywhere. And it's very easy to say, well, of course, they generate value, so why wouldn't we see them? We're pointing out that even if they don't generate value, you might see them. So there's some issue about efficiency, right? In the broader sense, where you don't necessarily conclude, even though everything here is voluntary, no one is forced to do anything and so on. There may not necessarily be value created just because people use the intermediary services. Okay, and that's due to this lack of commitment. So that's one observation. The second is that if you see noisy tests, you again, I mean, it's not something very strong, but it's still something, which is, you see noisy tests. One rationale for this is that it's difficult to get accurate tests. It's more costly, and we have an extension about that, and so on, right? It's just the technology is limited. What we're showing is that here's a natural reason why you would expect to see noisy tests, even if accurate tests are available and are available freely, right? So that's this additional thing. And the third point is that, in standard, and again, nothing here is particularly deep given the analysis, but it's an observation, which is in standard mechanism design, you would expect, when there's no information on the agent's part ex ante, you can extract everything by charging an upfront fee and then letting the agent learn the valuation, right, and just extract all the information rents up front. And what we show here is that A, you can't do that because you're going to generate other equilibria, and B, you can do better than that by having this disclosure fee later, right? So this additional instrument gives you something that you can't get with just this upfront fee, which you would in a standard design mechanism design institution. So that may be a justification for either, I don't know if this is a normative or a positive statement, right? But if you see this, you can explain it. And if you don't see it, then you can maybe suggest it. These are the thoughts I had in response to that comment.
Can I ask something along this line? So if you were actually having even more instruments, for example, you can disclose whether the price is between half and one. I mean, so you can partition, let's say, the price between 0 and 1, and then make different disclosures. Would that make any difference, or it would be would you get a higher surplus from that, or it would be equivalent?
Good. So this, I think, if I understand correctly, this is what you can think of as multiple pieces of evidence. Mm-hmm. So suppose you take a test and I give you, now instead of just giving you a score, I can give you stochastically from just a subset of pieces of evidence, and you can disclose any subset of what you're given.
Yeah, so it's like having a partition and then you reveal the partition cell, for example.
Something like that, right. That doesn't help. Turns out that doesn't help. Again, with this adversarial equilibrium selection, right? So the concern is that you would be able, because the concern in terms of the result would be that the intermediary would be able to guarantee herself something more, because by providing richer evidence space, she would be able to kill off these bad equilibria, right, that would otherwise arise in our model. But it turns out that anything that she can do with a richer evidence space, we can replicate with this simple evidence space. So you can't do more than that. And that's in one direction. And the other direction, the other two extensions are that even if you restricted the testing ability of the intermediary, either by having testing being costly or by just straight up constraining it, which is a special case, you would still get the same result, provided that the intermediary could always add more noise, namely that more accurate tests in the Blackwell sense are more costly weakly. Mm-hmm. Then the results go through.
Okay. So do we have any questions from any participants?
Can I ask a question? Mm-hmm. Maybe just very quickly. This distribution, this exponential thing, shows up quite a lot recently in a lot of papers. I'm thinking of the series of paper Bala-Shentes, as with Anne-Catherine Rösler and so on. And there's similar questions, right? I mean, this is right from the hip. I don't really have anything more than an intuition that the distributions look alike. Can you guys shed some light on this? Is it just a coincidence, or is there more to that?
Yeah, so as far as we understand, it is a coincidence. We have a detailed footnote in there that elaborates on this, but what they're doing, what they find is this isoprofit demand curve, where every price gives the same profit to the monopolist. Here, that's not the case, right? What we have here is this continuum of equilibria, and it turns out to have, there's this kind of, it's not an indifference condition in our setting, right? It's just saying there's an equilibrium for this score, for this score, for this score, for this score. In their setting, it's an indifference condition that the same profit is generated for a continuum of prices. That's not true here, right? The intermediary is not getting the same profit across all these equilibria. The agent is not getting the same payoff in all these equilibria. So I don't think we have anything. We're looking we couldn't find anything deep that connects the two, I think, beyond the technical similarity of some equations. Right, Nageeb? I think that's
Yeah,
what
and yeah, just to speak a little bit more to that similarity, it's kind of amusing to think why the term E comes up in both their paper and our paper. In their paper, it's coming up because you're integrating this unit elastic demand curve is like integrating a 1/x function at some point. So you get an E from that. From us, it's you were trying to really maintain this, and this came up in the differential equation, you're trying to maintain like a constant hazard rate. You're trying to create a distribution such that that integral divided by the derivative, or the function divided by a derivative, is equal to the disclosure fee. And so you actually do get, the demand curves are different, and you do get different distributions that come out of it, both of which involve the term E.
Okay, thanks.
Okay, if we have no other questions or comments, maybe we can stop the recording and then